Okie dokie. Today we're going to be doing a little bit of particle physics. So let's get started here. We're going to be looking at this reaction right here where a pi negative meson disintegrates into a mu minus meson and anti-mu meson neutrino. So let's take a look at that. The pion will start at rest with the velocity equal to 0, of course. So let's take a look at what we got here. Here's our question. If the pi meson decays from rest, what are the kinetic energies of the mu meson and the anti-neutrino of the anti-muon neutrino? Okay, we'll keep a couple of things in mind, and that is that the rest energy of pi meson is 139.6 mega electron volts, and the rest energy of the mu meson is mu minus meson is 105.7 mega electron volts. So let's take a look at our reaction here. What we're going to do is, here's our reaction. We're going to write each particle into simpler terms like A and B for the A for the pi meson, B for the mu meson, and muon for the muon, and C for the muon antineutrino. So we'll have these three letters, and this is our formula that we'll be using to calculate energy of the anti-muon neutrino. The energy C, that's the total energy of the muon neutrino. And that's going to be the rest energy of A, which will be the pi minus meson, squared minus the rest energy of B squared over 2 times the energy of A, the pi meson there. I'm not going to show the derivation of this formula. I will if this lecture becomes popular enough and people complain about wanting to see the derivation, or if I'm so inclined. Sometimes I'm inclined to show it if I have nothing to do. Okay, so again, the C particle is the anti-muon neutrino, so we've labeled that way. And here's our pi minus energy, rest energy, muon rest energy, and the pi minus energy. And we know, do we know these numbers? We sure do. I gave them to you already. And that is that the pi rest energy is 139.6 MeV. The mu rest energy I gave right here was 105.7 MeV. And the pi, again, is 139.6, just like there. These two are the same right there. So we get the energy of the anti-muon neutrino to be 29.8 MeV. That's the total energy of the muon neutrino. We believe that all neutrinos have a zero mass. So not only is this the total energy of the muon neutrino, but it's also the kinetic energy of the muon neutrino, since the muon neutrino has no rest mass. Okay, or none that we can measure so far. So that'll give us the total energy and the kinetic energy of the muon antineutrino. To figure out, we want to still find out what the kinetic energy of the mu minus the muon minus is. So we'll have a new energy equation, namely that the total energy of A has to equal the total energy of B plus the total energy of C. That's a conservation of energy, of course. And we'll go here, and the energy of A, of course, is the pi meson So we have that there. The energy of B is the mu meson, the total energy of the mu meson. The energy of C is the antineutrino mu for the muon. So we have this formula, and remember that the pion started from rest. I told you over here V equals 0, and in the question I said from rest. The pion is from rest. So the total energy of the pion will be the rest energy of the pion. And we know what the rest energy of the pion is. I gave it to you right there, 139.6. And if we do some algebra, we'll solve for the total energy of the mu meson. And that'll be this minus this, of course, algebraically. Then we know the total energy of the antineutrino for the muon is right here, 29.8, and we'll plug that in there. And we'll get the total energy of the mu meson is 109.8 MeV. That's the total energy for the mu meson. We asked for the kinetic energy. So if you want to know the kinetic energy of the mu meson, it'll be the total energy of the mu meson minus the rest energy of the mu meson. We know the total energy of the mu meson is 109.8. I put that right in there for this. The rest energy for the mu meson I gave to you right here. It's 105.7. And so if we take this minus this, we'll get the kinetic energy of the mu meson, which is 4.1 MeV. Okay? Well, we just saw particle physics interaction. This works, this formula works mainly when this thing is a massless particle here. So if this is a gamma ray or an X-ray or whatever, a neutrino, and these two have masses, this will work. Also, this particle has to be at rest and so on to use it. So try to use reactions like this. To use this formula, try to do it only for reactions that look somewhat like this. Okay? I hope you enjoyed this lecture, and I look forward to any comments on the bottom. Thank you.